Okay. So this quiz is going to cover everything we've done with derivatives so far. And I think what we learned by doing this homework assignment is that it's easier if you can simplify your problem first, isn't it? I mean, product and quotient rules are great, and sometimes we don't have any other option. But if we do have an option, it is way easier to distribute something at the beginning versus trying to do that product rule, and then you have multiple things that you have to multiply through later on, and it gets a little ugly. So keep that in mind on this quiz. I'm not going to say you have to do this problem this way. I'm just going to say find the derivative, and you can do that however you want. So let's look at some types of problems that I might put on there. So if I said 3y minus 4 squared, let's say, all right, so if I asked you to find this derivative, what would you do first? That square just means there are two of these. So we can write it twice. We can either do the product rule right here, or we could just FOIL. It would probably be easier just to FOIL. So if I did that, 3y times 3y is 9y squared, minus 12y minus 12y, so minus 24y, plus 16. So I haven't done my derivative yet, I've just been simplifying. But now this is something that we can very easily do the derivative of. What would that be? 18y to the first minus 24, and what's the derivative of 16? 0. So that's my answer. So simplify first, it will help. Let's say I told you that f of x equals 1 over 5 minus x to the 4th times x. What would you want to do here? Distribute. On the bottom, wouldn't it make the most sense just to run that x through? And that will avoid the product rule coming up. So that gives me a 5x minus an x to the 5th. Okay, is there any way to write this without a quotient? No. So at this point, we have to do quotient rule. So quotient rule is low, so the bottom. D high. What is the derivative of the top? 0. Minus high. D low, derivative of the bottom. Over low squared. Alright, 0 times anything is 0, so this whole piece is gone. If I distribute my negative 1, we get a negative 5 plus 5x to the 4th over 5x plus minus x to the 5th. Squared. And that is our final answer. So far, so good? Let's do this one. Alright, we have two options on this one. What's one option? Quotient rule, and that will work. What's another option? Okay, since there's only one term on the bottom, could I go ahead and divide these? Do each thing over t to the fifth and simplify it some? Yeah, you'll get the same answer both ways. Which way do you guys want to do it? Divide by t to the fifth. I think that would be a lot easier. So when you do that, t to the first over t to the fifth, you subtract those exponents. So 1 minus 5 minus 4 over t to the fifth. That would be 4t to the negative 5. So then my derivative, f prime of t. Exponent comes down, negative 4 comes down. T, if you subtract 1, negative 4 minus 1. Next one, if my negative 5 comes down, I have negative 4 times negative 5, so that's a positive 20. T to the everybody with me there? Problem 4. Do you have any questions? So what would we do with this one? Move it to the top. So how would you rewrite 2 over z? 2z minus 1 over z squared is z to the negative 2 minus 9. So then this derivative is z. Exponent comes down, so 2 times negative 1 is negative 2. Z, negative 1 minus 1 is negative 2. This one, negative 2 comes down, so negative times negative is a positive 2. Z, negative 2 minus 1 is negative 3. And the derivative of 4 is 0, so that's gone. Alright, notice how much easier these problems are if we simplify first. Saves a lot of time. Alright, a couple more. What do you want to do? Distribute. Okay, so this becomes 3w to the 7 minus. Okay, how could I rewrite this? It's like 2/5 w to the negative 7. So when you multiply it with w squared, you add those exponents. So we get 2/5 w to the negative 5. So derivative, exponent comes down. So 3 times 7 is 21. W, 7 minus 1 is 6. Bring down the negative 5. Negative 2/5 times negative 5. Positive 2. W to the negative 6. Alright, last review problem. Yes.
I have a question. Why can we not simplify it? There's more than 2 on the bottom.
Yeah, if more than one term on the bottom, you can't divide them. So let's do one like that and just make sure we see the difference. So if I said find the equation of the tangent line y equals 2x plus 3 over 2x minus 1 at the point 1, 5. So this one we can't just divide each term because we have two things on the bottom. Now if it were just a 2x on the bottom, we could put each thing over 2x and simplify. But since we have more than one term on the bottom, we cannot. Equation of a line, we need a point and a slope. How do you get the slope of a tangent line? The derivative. So since we can't simplify, we have to do quotient rule here. So that's low, so at the bottom. D high, derivative of the top. 2 minus high, 2x plus 3. D low, derivative of the bottom. Over low squared. So if we distribute, we get 4x minus 2. I'm going to distribute my negative and my 2 on this one. So minus 4x minus 6. So the 4x's cancel. Negative 2 minus 6 is negative 8 over the 2x minus 1 squared. So to find the slope, what do we have to do? Plug in the 1. So 2 times 1 is 2, minus 1 is 1, squared is 1. So my slope is negative 8. So then we can plug into y equals mx plus b. Our equation of the tangent line is negative 8x plus 45. So I really am doing...
Wait. Should it be negative 8?
Huh?
Negative 8 times 1 basically.
Oh, did I do negative 8 times 5? Yeah,
No.
just making sure you were awake today. Sorry about that. How about negative 8x plus 13? Did you have a little panic moment there?
Oh, it's
I've been doing that a lot this week. I think I need to sleep more. Alright. So, these 6 problems, guys, I've given you a really good idea of what your quiz is going to look like here. And kind of some of the tricks that you might need to help you on that quiz. What I would like to do now, I have this handout. we're going to do a few of them together.
Sorry.
You're fine. Okay, so number 1. So this is one that we could choose to multiply it out to begin with, but I'm going to practice the product rule, so I'm not going to multiply it out yet. So the derivative, y prime or dy dx, it is helpful for me if you kind of mark when you start your derivative versus if you're just simplifying first. And if you did choose to distribute, that is perfectly okay here. So the product rule says you do one derivative at a time. So the derivative of this first thing would be yeah. So the derivative of the first times the second one plus the first times derivative of the second one would be so now we could clean this up a little bit. If we distribute, we get negative 6x to the 7th minus 6x to the 6th minus 15x squared. This one, if we FOIL, negative 10x to the 7th minus 8x to the 6th plus 40x to the 4th plus 32x cubed. Then add like terms. So negative 16x to the 7th, negative 14x to the 6th, and I have a 40x to the fourth, a 32x to the third, and negative 15x squared. It doesn't matter what order you write those terms in. I just put them in decreasing order, but that's not required. Is that one all right with everybody? Let's do one more product rule problem together. Do you guys have a preference? Let's do number 3 then. So, again, if you want to multiply this out first, you can. I'm not going to just practice my product rule, but choice is yours for the rest of the homework. So, derivative of the first. What's the derivative of this first term? Times the second, so the second one doesn't change, plus the first times the derivative of the second. So now we could clean up our derivative by distributing everything. So we get negative 48x to the fifth minus 24x cubed, 60x to the fourth, 30x squared. This one, if I distribute my negative 8x, thank you. Add like terms, we get negative 72x to the fifth plus 100x to the fourth minus 24x to the third plus a 30x squared plus a 16x. And all of these problems are pretty much the same on here. There's no tricks, it's just straight practicing this technique. So for the other 3 like this, you can either distribute first or do this product rule like we've been doing. Are those 2 okay with everybody? Okay. Let's do a couple of the quotient rule problems. Let's do number 9 together. Okay, so on this one, we cannot simplify it first, so we have to go ahead and do our quotient rule. So that's low, D high, derivative of the top would be minus high, D low, derivative of the bottom, over low squared. So if we distribute, we get 45x to the fourth minus the 36x squared. I'm going to distribute the negative and the 10x. Negative 30x to the fourth minus 50x. Combine like terms, so that's 15x to the fourth minus 36x squared minus 50x over the 5x squared minus 4 squared. I'll do one more. How about number 8? So, low, that's the bottom. D high, derivative at the top would be minus high, so the top. D low, derivative of the bottom, over low squared. So if we distribute, we get 12x to the 6 plus 12x cubed. This one gives me 9x to the 6. Actually, can I go ahead and distribute my negative? Minus 9x to the 6 minus 36x squared. So 12x to the 6, then 9x to the 6 would be 3x to the 6. 12x cubed minus 36x squared over 3x cubed plus 3 squared. Does anybody notice something you could do to simplify this one? Now, you do have to be a little bit careful. And so if I take a 3 out, when I pull it out of the bottom, if I take a 3 out of this parenthesis, it's really 3 squared. So if I cancel a 3 out of everything, let me write this step to kind of explain what I'm saying. So on the bottom, since you could pull 3 out of that parenthesis because it's squared, it comes out as a 3 squared. So when you cancel a 3, you still have 1 3 left on the bottom because we only canceled one of them. That's also obvious if you actually FOILed out the bottom. You would see everything had a 9 in it. And so when you divide by 3, you're left with that 3. I'd like to just give you the rest of the class to finish up this handout.